Well, Zach, we have started the video, so everybody say hi.
Hi!
All right.
I got a name shout out specifically.
Zach did get a name shout out. Okay, so today, yes, Parker.
Can I go get a lollipop?
No, you may not go get a lollipop. Guys, this is not going to be what this video is about, right? This video is about refraction and ray tracing. So to do refraction and ray tracing, what I want to show you guys, I'm going to make a drinking glass because the purpose of refraction and ray tracing is to create something that looks like glass. And not only, we've talked about transparency before, right, which allows us to see through objects. This goes beyond that. This controls how light passes through an object and allows us to give reflections and more glass-like properties to our objects. So to demonstrate this, I'm going to make a drinking glass. So I've created a circle here, and I've set my fill type to n-gon. Same exact start for when we make a lighthouse, but we're going to be doing it a little bit differently today. So to make my drinking glass, I'm going to go ahead and enter edit mode, and I am going to extrude this drinking glass upward. But to simulate kind of a thick edge around my drinking glass, I'm going to go ahead and hit extrude again, and then just click. So I get that extra set of vertices. Just like when we create a balcony, we're going to do the same idea. Extrude, and then click. So now we have an extra set of vertices on top of our drinking glass. To get the thickness of the drinking glass, all I'm going to do is scale inward to about there. And it may be hard to see on the screen, but I've got this little lip now around the edge of my drinking glass that is no longer part of what I'm extruding. So to give my drinking glass depth, I'm going to extrude again and then just push this guy down instead of up. And I've kind of gone up, in, and back down again to create the edge of my drinking glass. Now it's kind of hard to see, I'm going to set this down for a moment, it's kind of hard to see how far down the drinking glass I am while I'm extruding. So one thing that you guys have actually done in here accidentally is used the Z shortcut. Can anybody tell me what the Z shortcut does? Anybody remember? Aries. Right, exactly. It enters what we call wireframe mode. So if I press Z, it takes away all the faces of my object and leaves only the points and the lines. So I'm going to take this little blue manipulator and I'm going to push this all the way down to the bottom of my drinking glass, and now that's about what my drinking glass is going to look like. So I'm going to get out of edit mode, and I'm also going to press Z again so that I have my finished shape. Now the lesson is not about making a drinking glass, the lesson is about how do we make our drinking glass look like glass. So that's what we're going to do right now. I am going to give my drinking glass a material, and the section that we care about when it comes to glass, there's two of them. We have the transparency section, and then below that we have the mirror section. Both of these are going to allow us to do some really interesting things with our materials. But to demonstrate that, I am going to add a plane in here. And I'm going to scale that plane up because we want to be able to see through our object. Let's see, where's my scale? All right, I'm going to make this 8. I'm going to make this 8. And I'm going to make my plane a color just so we can see the difference. So I'm going to go give it a material and then change the color of my plane. Hopefully everything I just did should be pretty familiar. That's stuff we've covered before, adding a plane, adding a material. But I want to put this plane here so that we can see what it looks like when I make my drinking glass glass-like. And just so I don't forget any of my vocab, I'm going to pull up my notes. So when we look at our Raytrace settings, or our transparency settings rather, we have already talked about Z transparency and mask. Those guys are our simplest forms of transparency. They just make our object kind of see-through. Raytrace is what we're going to use today because Raytrace not only calculates transparency, it also calculates how light passes through the object. So it preserves shadows and it allows us to kind of transform the light. If you guys have ever seen like how a reflection or something underneath water looks like it's in a different place than when it's out of the water and the light is being bent, that's what Raytrace does. It's responsible for bending light through an object. Okay, so with our Raytrace transparency set, we have a couple of options that I want to call out specifically. The first one is called Fresnel. Fresnel just means the amount of ray trace transparency. So the higher this value is, if I render right now, we can see that my drinking glass is not transparent at all. If I bump up my Fresnel value, so I'm going to bump this up to about 3, we can start to see that I'm getting a little bit of transparency in my edges here. Now notice that the inside of the glass is still blocking the light. I'm going to bump Fresnel up to 4 so we can see it a little bit clearer. But the outside of my glass is becoming transparent, just like I want it to be. The inside of my glass, however, is remaining solid. It's blocking that light, and that's causing a problem. So the other setting that we care about is depth. Just like with our fog, depth concerns how deep into the object the transparency goes. So if you can't see all the way through your object, that probably means that your depth value is set too low. So I'm going to bump this depth value up a little bit. And now we can start to see all the way through our shape. Now notice that because my Fresnel value isn't the highest value possible, I can still see the edges right here. So the little edge of my glass and the inside of my glass, that's still catching the light, or blocking light rather, because my Fresnel value isn't as high as it can go. I believe the highest Fresnel can be is 5, which should be, oh, maybe it goes higher, let's see. Oh, 5 is the highest. So this is as transparent as we can get with our ray trace value. Notice that these edges still catch light. That's the big difference between ray tracing and regular transparency. Regular transparency would make this evenly transparent, but ray trace is allowing the light to catch these edges as it passes through. If we don't like the fact that this is causing a shadow, then we would need to redirect our lighting or add another lamp on the other side to prevent those shadows from being cast. So it's all about how light plays with the object. Now I'm hoping that this plane will be able to allow me to demonstrate IOR, but we'll see. So IOR stands for Index of Refraction, and this is the last ray trace category that we care about. Index of Refraction controls how distorted the image looks. So if I'm going to increase this guy a little bit so you can see what I mean, bump this up to, let's say, about 2.5. And you can see that it's starting to introduce these imperfections into our glass. So index of refraction is creating more areas where the light is bent or refracted. And if we put something behind our drinking glass, like, let's put Suzanne back here. So here's Suzanne hanging out behind our drinking glass. We can see the lines a little bit better now. So Suzanne is helping to accent what that looks like through our object. All right, we covered depth, we covered Fresnel. Those are the only ones I care about right now. Drinking glass, we did that. Okay, so the last thing I want to show you guys real quick is our glass or mirror settings. And I'm going to do this on the plane to make it a little bit different so that we're dealing with something other than the drinking glass. So if I go to my material on the plane and I check where it says mirror, that allows my plane to become a reflective surface. So meaning that anything that's above my plane, the plane should show a reflection of. And these reflections are calculated automatically by Blender. The big problem with ray tracing is that it is slow. Some of you guys have noticed that if you try to do a lot in Blender at once, Blender really bogs down. Ray tracing causes that more than most things in Blender. Being able to calculate shadows and reflection are a really complex computer operation. So Blender has a hard time doing it. Meaning that if we can get away without using ray tracing, then we probably should. But if we really need something to be a mirror, then we can check mirror and we can increase this reflectivity value. So I'm going to bump that up. We'll bump it up about halfway. And let's see how that changes our look. So you can see already that the rendering takes much longer, but the surface now has an image of Suzanne and an image of the drinking glass. So with just one setting, we're able to completely reflect whatever is facing this plane. Yes, Parker?
The mirror isn't like the mirror isn't like reflecting the see-through.
Right, it's not. So, oh, I see what you're saying, because we can't see Suzanne behind the reflection.
Yeah.
I'm not actually sure if we can change that. But that's an excellent observation. It may be that when Blender calculates its reflections, it does it based on the object and not the material setting. So that might be possible as well. Because the other thing you'll notice is that if I were to make Suzanne blue, actually we won't use blue because the plane's already blue. If I were to make Suzanne hot pink, all right, hot pink. If I were to make Suzanne hot pink, we're going to see, hopefully, when I render my image, that Suzanne has a bluish hue because the thing that's reflecting her is blue. So even though she shows up purple, she's got this bluish hue over her. I'm guessing the reason that the drinking glass isn't see-through is because the material of the reflective surface is not absorbing the transparent properties, or it's not accurately reflecting the transparent properties. But that's actually a good catch. I've never noticed that before, Parker, that it doesn't reflect the transparency. So what I want you guys to do today, and it shouldn't take that long, hopefully. We've got 15 minutes until we're going to go out to the auditorium, and then when we come back, we will finish up anything that we haven't finished already. Also, everyone say bye to YouTube.
Bye.